Hello, in this video we are going to learn about right triangle trigonometry. So to begin, we need to discuss trigonometric functions. Well, of course, we're talking about right triangles, which is notated by the square in the corner. And the side directly across from this 90-degree angle is our hypotenuse. If we're looking at the angle on the bottom, the side directly across from it is the opposite. And the side touching the angle is the adjacent. Now what happens if I move my angle to the top? Well, now the side directly across from it's at the bottom, so we need to switch these two sides. And that was just a review on how to identify your opposite and adjacent sides, because if you're unable to identify those two sides, you will not be able to apply the trigonometric ratios correctly. So let's look at our trigonometric ratios. Sine is the opposite side over the hypotenuse side. Cosine is the adjacent side over the hypotenuse side. Tangent is sine over cosine. Make sure you simplify it. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. And cotangent is cosine over sine, or the reciprocal of tangent. So evaluating all 6 trigonometric functions using the triangle below. Here we're looking at the bottom angle, and we know that our two legs are 3 and 4, but we do not have our hypotenuse. So how are we going to find this third and final side? Pythagorean theorem. So we know our two legs, which are A and B, so we're going to plug them in because we're looking for C. 3 squared is 9, 4 squared is 16. Adding those together, you get 25. Square rooting both sides, we now know that C is 5, so we can replace our question mark with a 5. Now it's time to start applying our trig functions. Sine is opposite over hypotenuse. Looking at our theta, the side directly across from the theta is 3 and our hypotenuse is 5. So sine is 3 over 5. Cosine is adjacent over hypotenuse, so the side directly next to our theta is 4 and our hypotenuse is 5. Now tangent is sine over cosine, so 3/5 over 4/5, and simplifying that, we're going to get 3/4. Cosecant is the reciprocal of sine, so we're going to flip 3/5 to become 5/3. Secant is the reciprocal of cosine, so we're going to flip 4/5 to become 5/4. And cotangent is the reciprocal of tangent, so instead of being 3/4, it is now 4/3. Okay, in this example, we're going to still find all 6 trig functions using a triangle. However, this time we're looking at the top angle instead of the bottom, and we have a leg and a hypotenuse instead of having our two legs. So we still need to find the second leg using Pythagorean theorem. Since we know a leg and a hypotenuse, we know A and C. 9 is a leg, so it's A. 15 is C, hypotenuse, so it's C. 9 squared is 81, 15 squared is 225. Subtracting 81 from both sides, B squared is 144. And square rooting both sides, B is 12. So now we know that this bottom leg is 12. Now it's time to find our 6 trig functions. All right, sine is opposite side over hypotenuse side. So looking at theta, directly across from theta is 12. Our hypotenuse is 15, so sine is 12 over 15. But we can simplify these by dividing by 3, so it simplifies to 4/5. Cosine is adjacent over hypotenuse, so the side adjacent to the theta is 9, and our hypotenuse is 15. Simplifying that by 3, we get 3 over 5. Tangent is sine over cosine, so you could have said 12 over 15 over 9 over 15. And that would have simplified to 12/9, and you would have got 4/3. Or if you would have done 4/5 over 3/5, you still would have simplified to 4/3. All right, cosecant is the reciprocal of sine, so instead of being 4/5, it's 5/5, 5/4. Secant, instead of being 3/5, it is 5/3. And cosine, instead of being 4/3, it's 3/4. Now in this next example, we're finding all 6 trig functions. However, instead of giving you a triangle, I told you that secant is 3. So let's dive in. Looking at our trig functions, what do we know about secant? We know secant is 1 over cosine. So we need to write secant as a fraction. It's a whole number. We know all whole numbers are over 1, so it's 3 over 1. Now we know that this was the reciprocal of cosine. So that means that cosine had to be 1/3. Knowing that cosine is 1/3, we can fill in our triangle because we know that the adjacent side is 1 and the hypotenuse is 3. To find our third side, we can use Pythagorean theorem. A squared plus B squared equals C squared. A is 1, C is 3. 1 plus b squared equals 9. Subtracting 1 from both sides, b squared is 8. Square rooting both sides, b is 2 square root of 2. So now we know that this bottom leg is 2 square root of 2. So let's finish finding our other 4 trig functions. Opposite over hypotenuse. Opposite of our theta is 2 square root of 2, and our hypotenuse is 3. We already know cosine, so we can move on to tangent. Sine over cosine, 2 square root of 2 over 1/3. 2 square root of 2 over 3 over 1/3. And that's 2 square root of 2. Cosecant is the reciprocal of sine, so now we have 3 over 2 square root of 2. We don't like radicals in the denominator, so rationalizing our denominator, we now have 3 square root of 2 over 4. We already know secant, and cotangent is the reciprocal of tangent, so 1 over 2 square root of 2. Rationalizing our denominator, multiplying the top and the bottom by square root of 2, we get square root of 2 all over 4. Now let's talk about trigonometric identities. What we've been using this whole entire time has been our trigonometric identities. Knowing that sine is opposite over hypotenuse. Knowing that cosine is adjacent over hypotenuse. Tangent, sine over cosine. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. Cotangent is the reciprocal of tangent. These are our most basic trig identities. There are so many more, but we're going to use these right now. Let's look at this problem right here. Tangent theta cosine theta equals sine theta. We're going to use our trig identities to prove that that is true. So the best way to do this is to get everything written in terms of sine and cosine. The only thing that I see in this problem that is not written as cosine or sine is our tangent. But what do we know about tangent? We know that tangent is sine over cosine. So I'll replace tangent with sine over cosine. Now this is a fraction, so to work with it, we need to look at cosine being a fraction, cosine over 1. I see a cosine theta on the top and a cosine theta on the bottom, so those divide out to 1, leaving me with sine theta over 1. But I know that anything over 1 is just that thing, so sine theta equals sine theta. So we have proved that identity.